This is lesson 4 for chapter 2 rational numbers. So we're going to begin problem solving with rational numbers in decimal form. So by the end of this lesson, you should know how to set up and solve a problem involving order of operations and involving rationals that are in decimal form. These rational numbers will also be integers. So remembering your integer sign rules. So this first example says on a Saturday, the temperature at the blood reserve near Standoff, Alberta, decreased by 1.2 degrees Celsius per hour for 3.5 hours. It then decreased by 0.9 degrees Celsius for 1.5 hours. So I want you to take a moment and read through this question and pull out all the important information, come up with what integers you're dealing with before you start looking at letters A and B. So take a minute and pause this and look through the important information. All right, so the first decrease in temperature was 1.2 degrees Celsius per hour for 3.5 hours. So decreased in temperature, that means we have a negative temperature change for 3.5 hours. The second temperature change we had was also a decrease, and the temperature decreased 0.9 degrees Celsius per hour for 1.5 hours. So we have two different brackets that we can multiply. In order to find the total decrease in temperature, we're going to add these afterwards. If you wanted to, you could actually write it as one full equation and then add together, making sure that you follow your order of operations and do all of your brackets first. So that's why I put everything in brackets. So the first decrease in temperature was negative 4.2 degrees Celsius. And in the second set of time, the temperature change was negative 1.35 degrees Celsius. And so we have these two values being added. So it went down 4.2 and then it went down another 1.35. So the temperature should be more negative, and we end up with negative 5.55 degrees Celsius. So the temperature went down 5.55 degrees Celsius in that time. Now I'm asking for the average rate. So the average rate means that in those total hours, what was the average change? We know that the first 3.5 hours, the temperature changed more quickly than the last hour and a half, but we're looking on average. And so in order to know an average, we need to know how many hours we're dealing with. So our total time is 3.5 hours and 1.5 hours. So our total time was 5 hours. In that total time, our rate, so our temperature decreased by 5.55 degrees Celsius per 5 hours. So when we divide those, we get a rate of negative 1.11 degrees Celsius per hour. And both units stay, they don't end up canceling each other out. When we look at the next example, I want you to do something similar. I want you to look and see and read through the problem and find out the important piece of information. So pause the video, read through, highlight, underline an important piece of information, and then start the video again. All right, so in this problem, there's two ways we can approach it. So it says Bart owns 125 shares of an oil company. One day, the value of each share, so each of the 125 shares dropped by 31 cents. So he lost 31 cents 125 times. The next day, the value of each share rose by 18 cents. So he gained 18 cents 125 times. What is the total change in the value of his shares? So there's two ways we could solve this. We could find out how much he lost on day 1, and then how much he gained on day 2 and find out what that difference is. Or we could find out how much the shares changed by, so comparing the 31 cents and the 18 cents. First, I'm going to show you both methods. You decide on which one you want to try. So pause the video, try it, and then check your solution. All right, so here's both solutions. If you look at the solution on the left, we did 125 shares times negative 31 cents. And so they get multiplied. And so on day 1, he lost $38.75. So negative $38.75. On the second day, he gained 18 cents, so 125 times positive 0.18 to earn 22.50. So because he lost more the first day, when we combine those two values, negative 38.75 plus 22.50, there's still a negative 16.25. So over the course of the 2 days, he lost $16.25. Because we're talking about money, make sure you have a dollar sign in your solution. On the right-hand side, we have 125 times negative 31 cents plus 18 cents. So we're finding the difference in the money instead of finding the difference in the total, like we did on the left side. So negative 31 plus positive 18 gives negative 13 cents. So overall, the shares lost 13 cents per share. So we go 125 times negative 13 cents, again, gives a negative $16.25. So either way you solve, you still get the same loss. The total change in the value are lost $16.25 total. Okay, and again, we wouldn't say lost negative 16.5. The lost already indicates a negative value. So the next thing is, what is an average rate? And so if you remember from grade 8, we talked about rates, and sometimes we talked about a rate as just comparing two different sets of values, like money, like temperature in hours, like kilometer in hours, like dollars per unit, or something like that. And so when we're talking about average rate, again, we're talking about the comparison of two different types of units, and we're talking about the average amount of it. So the most common example you'll see of average rate is the change in a value, and that could be distance, like kilometers or meters or centimeters. That could be temperature in degrees Celsius or degrees Fahrenheit. It could be money, and it's usually a change in value over a change in time. And so our time could be in minutes, could be in seconds, it could be in hours, could be in days, could be in weeks, could be in years. So that's what an average rate is looking for. So for example 3, examples like this, I strongly encourage you to draw the scenario out. It will really help you visualize what is actually going on. So this first example says we have a pelican. If you don't know what a pelican is, it is a bird. So I'm going to draw a bird. Beautiful bird. And he is diving vertically, so he is diving down from a height of 3.8 meters above the water. So I've got water, and I've got this pelican diving down. So I'm going to use negative to show that he's going down 3.8 meters. And then he hits the water line. He then catches a fish that is 2.3 meters underneath the water. So I'm going to draw a fish, and the pelican, well, I guess I've got to move the fish over so the pelican can catch it. There. So then the pelican dives another 2.3 meters, and he's diving down, so we're going to use a negative, and then he eats the fish, and then I assume he swims back up. So the first question says, write an expression using rational numbers to represent the length of the pelican's dive. So we can see that he dove 3.8 meters towards the water, down, and then he dove another 2.3 meters under the water, again, still going down. So if we're going to write the expression, we're going to use negative 3.8 meters plus negative 2.3 meters. Because his full dive is actually this full length. It's both of those measurements together. So how long is his dive? Well, negative 3.8 and negative 2.3. The total dive is negative 6.1 meters. Or we could say 6.1 meters down. Again, we can use the word to show the direction, or we can show direction with the negative sign. Okay, we have another water example. So at this example, we have a submarine cruising at a depth of 153 meters. So depth, again, is meaning underwater, so negative 153 meters. And the submarine then rises at a rate of 4.5 meters per minute for 15 minutes. So I want you to take a second and pause the video and draw what this scenario looks like. Okay, so here's my drawing. You can't tell, we've got the blue waves of the water, we've got a green submarine, and the submarine is 153 meters below water, so negative 153 meters. And the submarine in blue is going up 4.5 meters per minute. And the question tells us that it does this for 15 minutes. So the first question asks us, what was the submarine's depth at the end of this rise? So it's going up 4.5 meters every 1 minute, and it does this for 15 minutes. So it does this 15 times. So we multiply, and so the submarine rises 67.5 meters. So that's how far it's come up. Okay, so I'm going to change something on my drawing here. I'm going to erase this rate, and I'm going to show the amount that it traveled. So it went up, so plus 67.5 meters. That doesn't mean that the submarine is now in a positive 67.5 meters. So it's not 67.5 meters above the surface. The submarine has only gone up 67.5 meters from where it started, which was negative 1.3. So what the question is asking us is, what is this space that's left? Well, that's the difference between negative 153 and positive 67.5. So we're gonna add these up. So negative 153 meters plus 67.5 meters. And so the submarine is still at a depth of 85.5 meters. And the negative tells us that he's underwater. The negative is showing the direction. So now, if the submarine continues to rise at the same rate, how much longer will it take to reach the surface? So the submarine still has to travel 85.5 meters until the surface. So we have to think, okay, how many times does it have to travel 4.5 meters in order to make up that 85.5 meters? So the easiest way to do that is to go 85.5 meters. In this case, we don't need the direction, so we don't need the negative sign. The negative sign is just telling us that it's below water. We're going to divide it by the 4.5 meters per minute, which is the rate. And when we do this, we get a time of 19. I want you to notice that the meters are going to cancel out. Meters on top and meters on the bottom are going to cancel out. And then the only thing that's left is minutes. So 19 minutes. So how much more time will it need? The submarine will need another 19 minutes. Or the total time would be 19 minutes plus 15 minutes. So 34 minutes altogether. But 19 minutes longer. All right, last example. I know this video is a little bit longer, but I want to make sure we explain the word problems. Okay, again, I would like you to pause and read through this question and underline and pull out any key parts and what you understand from what the question is telling you, and then restart the video. Okay, so this company made a profit of $8.6 million in its first year. When we say profit, that's a positive value, it's gained. It lost $5.9 million in its second year, so losses we use as negative values. And it lost another $6.3 million in its third year, so again, another negative value. So before we can answer the question that says, what is the average profit, we need to figure out what is the total profit or loss in the 3 years. So the way that we do this is we add those three values. I'm going to drop the million and I'm just going to add the decimals. We'll add the million back at the end. So we have positive 8.6 million, negative 5.9 million, and negative 6.3 million. And when we add these values up, we end up with negative 3.6 million. So the company lost $3.6 million in those first 3 years. Once we add the 3 up. Yes, there was a gain in the first year, but the losses in the following 2 years ended up that in those 3 years in total, they lost money. So in order to find the average, it's the change in a value over a change in time. So we have our change in a value, we have negative $3.6 million, and the time is 3 years. So the way that we do this, we want to know what was the average in 1 year, so we're going to divide by 3, and we get negative $1.2 million. So on average, the company lost $1.2 million per year. So now, the second part of this question asks you, in 4 years, the company broke even. So what that means is they didn't make any money, but they also didn't lose any money. So they ended up at 0. So I want to know how much did they either make or how much did they lose in that 4th year to bring their total profit or loss to 0. So I want you to give that a try, pause the video, and then double check. Okay, so if you said positive $1.2 million had to be made in that 4th year, you were wrong. That was the average. What you should have done is realized that this negative $3.6 million needs to be canceled out to bring them to 0 for that 4th year. So again, thinking of opposite integers, negative 3.6 is going to be canceled out by positive 3.6. So in the 4th year, they had to make a positive $3.6 million to make the total profit or loss to 0. All right, so that's your last example for this lesson. Again, tomorrow we will look at these practice questions in class. I encourage you to take a look at them ahead of time and see if there's any ones that stand out to you as problems that you might not be able to answer, so we can address them in class. Question 29 is more of a challenge problem. So if you are somebody striving for excellence, you definitely need to give that one a try. And if you are struggling with this unit, that one might be one you want to give a miss. I would definitely take a look at it, but it might be too challenging at this stage. This is going to be your last lesson before a quiz. So once you're done this assignment, be ready for your first quiz.